Page 103. A kite is flying at a height of 50 feet. If the string makes a 30-degree angle with the ground, how long is the string? So in this particular situation, we know hypotenuse and we know opposite. And I'm not even going to mark adjacent because I know this is a sign problem. That's the purpose of doing this set of problems, is so that we can see sine and cosecant. So if you work this the way we've been working it, nothing's changed. You know the hypotenuse is what you're looking for, and you know that your opposite is 50 feet, and you know your theta is 30 degrees. So I'm going to do the sine of 30 degrees equals opposite over hypotenuse. So I will multiply both sides by s so that I can eliminate this fraction. And then I'll have to divide both sides by the sine of 30 to move it away from s here. So s equals 50 divided by the sine of 30. And that is going to be an even answer of 100 feet. So the kite string is 100 feet long. Now, if you want to do this with the cosecant ratio, remember that cosecant is the same as the reciprocal of sine. Cosecant is also defined as the reciprocal of sine in that it is hypotenuse over opposite. Remember, sine is opposite over hypotenuse. Let me just write that up here. Sine equals O over H. So cosecant, which is the reciprocal of sine, would be the reciprocal of that, or H over O. So we're going to use those two formulae. And let me just make a copy of these. Actually, let me highlight it first. I need these two pieces of information to solve these problems. And in your electrical courses, you're going to use sine and cosecant. So that's why we're spending the time on this, just so that you get to be familiar with these two processes. So I know that 1 over the sine, and in this case our theta is 30, is going to be equal to H over O. And H we don't know, we're calling that the string, but O is 50. And if you set up these two ratios as a proportion, then you can solve this. So you would be multiplying 1 times 50, which is 50. And then you would be multiplying sine times s, which is our hypotenuse. And so to get s by itself, we need to divide both sides by the sine of 30. And that brings us back to our original right here. These are the same ratios. So we will have 100 equals the length of the string, and that is 100 feet. So you can use sine or cosecant to get the same answer. And that's what we're going to be practicing throughout here. We're going to do it with the sine ratio and then with cosecant. A 20-foot ladder leans against a wall at a 60-degree angle with the ground. How high does the ladder reach on the wall? So we're looking for this height of that point, and that is going to be the opposite. Here is hypotenuse, the ladder. So we know the 20 feet. We know theta is 60, and we're looking for opposite. So sine of 60 would be equal to opposite, that's the wall, over adjacent is the ladder. I'm sorry, over hypotenuse is the ladder. And then we'll multiply both sides by 20. So the height on the wall is going to be 20 times the sine of 60. So about 17 point, I didn't do a rounding rule. Let's do it to hundredths on this page. And that is feet. If you go the cosecant route, you know that cosecant is 1 over sine. And we also know that cosecant is hypotenuse over opposite. So that would set up this proportion. So we get 20 times the sine of 60 equals 1 times W. So W is approximately 17.32 feet. And you may be thinking, why would I want to do this one if I can do it this way? Or why would, really the question is, why would I do this one if I can do it this way? And the reason that I'm showing you both, aside from just needing to know that they are related to each other, is that my calculator will not do cosecant. Okay. A satellite dish is tilted at a 35-degree angle. So here's the dish. It's tilted at 35 degrees. If the signal travels 100 feet along the tilt, that's the hypotenuse, what is the vertical component of travel? So we want to know this one. We know the path of the signal. We want to know the vertical height. So we have opposite that we're looking for. We have 100 feet for hypotenuse and 35 degrees for theta. So the sine function would give me opposite over hypotenuse. So that vertical distance is going to be about 57.36 feet. And then to visualize that with cosecant, I know that cosecant is hypotenuse over opposite. So let's just go ahead and plug in the numbers. We don't know opposite. And we know that cosecant is also 1 over the sine of theta. So I'm going to have 100 times the sine of theta equals 1 times v. So that's just v. And there again, about 57.36 feet. point here is that both the sine function and the cosecant function are getting us to the same answer. They are reciprocals of each other.